Good evening, ladies and gentlemen. Once again, my name is Dr. 𝗘𝗴𝗶𝗿𝗁 𝗃𝗏𝗄𝗏. I work with 𝗓𝗏𝗏 Metaverse. Tonight, we'll be coming to the concluding part of the training on engineering safety that has been going on for the past 3 days. We'll be having an eminent engineer here with us to talk about engineering safety in person of Engineer Nelson 𝗘𝗴𝗶𝗿𝗁. Over to you, Engineer Nelson. You just have a minute to talk about yourself. Then we'll move on to the business of the day for just 30 minutes, and we'll use the remaining time to take questions. Over to you, sir. Okay, we can't hear you, Engineer Nelson. Probably you might need to check your audio or... Okay, let me unmute you now. You can unmute yourself.
Oh, yeah.
Okay.
All right. Yeah. Can you hear me?
Yeah, I think you have two systems on. Maybe you have to put off one, mute the mic for one.
No, it's just my system.
There's a serious echo anytime you talk.
Okay, I'm trying to do something. Is it probably because I have the two Zoom platforms, showing something that it could be. Okay, let me put off one. Let me switch off one. Okay.
Yeah.
Is it better now?
Yeah, excellent.
Better now.
Yeah.
Okay, fine. Yeah. Okay, so Dr. 𝗃𝗏𝗃𝗏𝗃, thanks for having me. Good evening to you and to every other person that's on this call. You struggle to call my name. I think I have to I have to start there, but I get that a lot, and I also feel very proud. Almost all the time to also take my time to say my name again and again. I mean, it's
pronouncing it was supposed to be becoming a safety issue.
Yeah. The name, you need to study it for you to be able to actually call it. A very compound one anyway, ladies and gentlemen. I hope we have ladies here. We have ladies here too. It's always good to also know that ladies are interested in safety.
Thank you.
Do we have ladies in the house as well?
Yeah, we should. Definitely.
Okay. So the name is Nelson Ude, Engineer Nelson Ude 𝗘𝗴𝗶𝗿𝗁. So it's actually two names, just in case of next time. That 𝗘𝗴𝗶𝗿𝗁 is not, it's supposed to be pronounced like two names. There are two names joined together, actually.
Okay.
𝗘𝗴𝗶𝗿𝗁. Ude 𝗘𝗴𝗶𝗿𝗁. All right. Thank you very much. It's my pleasure to be here. And you already have read out my profile. I actually have, of course, over 15 years of safety management experience in various industries, like you rightly said. In order not to bore you further with that, I could just maybe add here that I actually started my safety practice in Nigerian Bottling Company. That was way back in 2008. I was the first safety manager in the Kano plant of the company, So that's where I worked, and then I moved from there after 2.5 years to 𝗏𝗂𝗋𝗋. 𝗏𝗂𝗋𝗋 was more like a national a safety role where I was, sitting ahead office and of course visiting all the sites 𝗏𝗂𝗋 had in Benin, Ikeja, and of course in Kaduna. So as a HSC manager, I had of course a couple of safety coordinators reporting to me. So I was with 𝗏𝗂𝗋 for 2 years, after which I again left and then joined the Nigerian Machine Tools Osogbo as a HSC manager. Is a steel rolling mill, a steel plant or factory. And then I worked there for a year, and then from there I moved and came back to Lagos and joined Niger Dock. Niger Dock is on the Snake Island and majorly into oil and gas, construction. So that's where the construction experience come in. We actually built the Egina FPSO. It's currently sitting on the Egina site producing crude. So that's a project took 4 years. I left after the completion of the project and joined again back in Coca-Cola. That was my second missionary journey. This time as a contract project manager for the expansion project in Maiduguri plant. So I did that for a year, and then another opportunity came up in the Abuja plant, which I had to leave Maiduguri and then came down to Abuja to become the plant safety manager again. Okay, in Coca-Cola Abuja. I was there for about 2 years and had to move again in 2021 to flour mills, specifically at the 𝗲𝗏𝗶𝗏𝗏 terminal, where I also worked as HS manager before I got a current role, which I hold in 𝗲𝗏𝗏𝗏𝗏. Okay, 𝗲𝗏𝗏𝗏𝗏 is into animal feed production, and I currently work at the head of HSE, in charge of all the locations that the business unit controls in Kaduna and in Ilorin, and So that is me. I hold a bachelor's degree in engineering, mechanical engineering. I also have now obtained a master's of science degree in environmental sustainability. I have various 𝗡𝗏𝗏𝗏 certifications. 𝗡𝗏𝗏𝗏 is actually a national examination board for occupational health and safety in the UK. There are various certifications that they do for those who really want to build a career in safety. I mean, it's not a local certification, and it's not actually advised for those who are just who don't want to develop careers in safety to waste their time going to obtain such quality certification. So it starts from the IGC, International General Certificate, and down to diploma level. Can you still hear me? Hello, can you still hear me?
Yes, I can. We can hear you.
Okay. Oh, okay. Yeah, so I have all of that. I'm also a certified auditor, and that's where the ISO 45001, that's the safety management system comes in. And before the ISO 45001 came on board, what we had was OSHA's 18001. That was Occupational Health and Safety Assessment Series. Okay, so that was now replaced in 2018 by the ISO 45001, which is the most recent safety management system standard that companies that are serious in ensuring safety of their workplaces actually try to get certification on. Okay, yeah, so like I've already said, I currently work for 𝗲𝗏𝗏𝗏𝗏. Yeah, I'm a registered engineer, with Koren, and of course you do know that studying engineering and having an engineering degree doesn't really make you an engineer or to be called an engineer until you are registered with Koren. So that's why you now see the title engineer. Nelson, recently registered with Koren. Okay, so that's about me. I hope I won't take too much time to talk about myself alone. I do know that I just have limited time to talk about engineering safety, or what I may call safety in engineering. Okay. For those of you, my listeners who are engineers or trained engineers, you would know that safety is a core aspect of engineering. Of course, in I think year 4, there's a course called engineering management, and of course, within the context of that course, safety management is always also talked about. And for those of us, those of you who may be, that are taking various roles in engineering, it could be engineering design, designing structures. It could be in operation of engineering facilities or equipment. Can even be in maintenance, of course, engineering facilities. So each of these aspects of engineering practice obviously require you to have in-depth knowledge of safety. Otherwise, you could have issues while carrying out those roles. That is why, even if I may digress a little or talk a little more about engineering safety or safety in engineering, we discovered that for those in design, it's what we normally call a factor of safety. That simply means that in every design you make, you have to also factor in the possibility of failure. Should it happen, what do you do? Or what happens, to prevent any failures? That's why the bridges, for instance, that are originally designed for point loads, okay, implying that you don't need to have materials or loads stuck on the bridge for a long time, okay. One may wonder, okay, why do such designs not fail or have not failed, especially in Nigeria where hold up, or in Lagos where hold up is a thing of the day? That is because a factor of safety has been included in the design Otherwise, one would have expected that once you have hold up on the bridge, it should collapse because the bridge wasn't designed for that kind of loading, right? Because it was originally designed for point loading, just pass, moving vehicles. But what do you have now? Sometimes we have the vehicles stuck on the bridge, and all that, but bridge still doesn't fail. What it simply tells you that there's factor of safety that is at work to keep the bridge still standing. So that is just that, and it's applicable in every field of engineering, actually. So safety is a core component of engineering. So for the purpose of our discourse this evening, I'd like to go further down by saying that a lot of accidents have happened because of personnel or workers, operators coming in contact with different parts of machines, especially moving parts of machines, or even machines that are powered, of course, by what we call hazardous energies. There are different forms of it. So for engineering safety that we're discussing today, I'd like to also state here that you've undergone the training, like Dr. Saze said, you would have done training recently on engineering safety. I believe also that hierarchy of engineering hierarchy of hazard control or risk control may have been mentioned or would have been mentioned. And within the hierarchy, I'm sure you would have been told that you have, of course, in controlling a risk or, preventing incident, what you look at first is elimination, right? You also from there, the second would be substitution, okay? And then the third, of course, in the hierarchy of control of risk would be the engineering controls. What does that really tell you? That most times you may not be able to eliminate the process, the work process, because you need to produce what you want to produce. And that defined procedure may just be the only way to have it done. You may not really have to, except you want to close shop. So elimination in some instances, most cases may not really work. The next will be substitution, substituting the hazard or the material producing the hazard with probably a lesser one. To some extent, too, it may not be possible. Even when it's possible, it may be costlier to have the substitution method coming. Then you are now left with the third one, which is engineering control. Engineering control seem to be the most affordable and very efficient as well to keep workers away from harm's way during the operation of any engineering infrastructure. So within that context, I'd like to talk about two aspects of engineering safety, okay? One, that is machine safety. And within this machine safety, we have two aspects, which is machine guarding or machine safeguarding or safeguards, and of course, hazardous energy control. I like to pause a bit. Let me just confirm that I'm still being heard, because it looks to me like I'm talking to myself. Are you hearing me, guys?
Yeah, we can.
Yeah, I can hear you, but are we sure the audience are also hearing?
Yeah, please, if you can hear him, just type yes and let's see. Oh, as you can see.
Okay, yeah, Oba Marvin says yes. Okay, thanks, Oba, for responding. So now I'm sure that I'm not talking to myself. So I was going to now go into the main aspect I want to discuss today, which is, of course, machine safety. Okay, and within the context of machine safety, I'd like to be talking about or to talk about machine safeguards or safeguarding, and also hazardous energy control. Okay. Now, these two aspects of safety have actually caused a lot of injuries and also fatalities on sites, on on workplaces or at workplaces during the course of whatever the work site is into. So they are very important that we understand this, because should anything go wrong, what you're likely to have is severe injury outcomes. It could be amputations, it could be serious injuries that can actually lead to deaths of the victim. So if you are in a site or working on a site or designing a project, whatever you are designing, engineering or infrastructure, you need to pay attention to how to mitigate any risk that are associated to the machine itself. Okay. So the first we are talking about is the machine safeguards. Within the context of engineering control for risk management, machine safeguards okay, or machine guarding sits within what we may call enclosure aspects, enclosure. What you are trying to achieve is to create distance or a barrier between the machine and, of course, the worker that is operating the machine. So you need to create a barrier, okay? So you at the point, the actual risky aspect of any machine is the point of operation of the machine, okay? Depending on the kind of machine, we have different kind of machines that we use in various industries. So the point of operation of that machine is where the worker is likely to be within to be able to operate the machine, right? Or to receive whatever product or item is coming out of the machine. So it's very important that machine safeguards, are in place so as to protect the worker from coming in contact with the point of operation of the machine, which is the dangerous or most dangerous part of the machine. So there are various types of machine safeguards, okay, that needs to be fitted to machines to make the machine safe for operation. So depending on what the hazard is, the hazard could just be moving parts of that machine, moving parts. It could be chain drives moving, it could be gas moving, it can be any aspect, maybe the different part moving, but the worker is within that point of operation. So creating a barrier, creating a guard, to separate the worker from that moving part, we just do the magic by protecting him. So like I said, there are different types of machine guards. Some of them can be as simple as physical, covers. You would have seen covers being placed over moving parts of machine. What it simply does is to protect the operator from having physical contact with that moving part. Okay, so you can have what we are now calling physical type of machine guards. Could be fences, can be ordinary covers, but of course it has to be suitable so that it's not defeated by just mere impact on it. So that's a very key aspect of machine safety. Please always ensure that every machine that has moving parts or where a worker is likely to come in contact with the point of operation of the machine are fully guarded. Okay, there are different types of machine, like I said. So because the question will be, what kind of machines really need these guards? So I'm saying to us now, it depends on the machine. So what do you only need to examine when you do your assessment as a safety or as an engineer or a safety professional or a maintenance person who doesn't want incidents, to ensure that you assess every equipment and try to identify the point of operation of that machine, okay, because that is where the hazard is. And then assess it to know how the operator could be harmed, either by making physical contact with the moving parts or by being, splashed with whatever is coming out. It could be dust, it could be liquid, it could be whatever, and as well splash on the operator who is standing by. So whichever risk it is, there has to be a way to separate the equipment, the operator from the equipment, and that is what I'm calling physical barrier or physical safeguard or machine guarding. Covers, fences, things like that, just to separate the operator from the point of operation of the machine. Okay. And then we can also look at some other kind of machine safeguards, like the sensors, what we call interlock guards. There are some sensors that, okay, if any part of a worker or the operator crosses a particular space, that machine shuts down. Okay, so or the machine does not operate at all. That's what I mean. So these are what we call interlock guards. So they're also applicable. So it really depends on the equipment and what kind of risk it presents. That will determine the kind of safeguard that need to be put in place. But I think the takeaway here should be that every point of operation of a machine that presents a risk to the operator or personnel around it should be guarded so as to prevent physical or bodily contact with that. Okay, either with the moving equipment or with whatever is coming out of the machine getting to the operator. Then the other aspect of machine safety to be worthy of being talked about at this program actually is the hazardous energy control. We do know that machines are driven by various energies: electrical energy, pneumatic energy, hydraulic energy, okay, gravity, and the likes. You name it. There are a whole lot of energies that drive machines. So what hazardous energy control simply means that you must be able to identify what hazardous energy drives any machine. It could be one, it could be more than one driving a particular equipment. Now, this aspect of this risk has also killed a lot of people or caused severe injuries in workplaces. You could have a situation where machines accidentally start during quick interventions on such equipment. An operator could be operating a bagging machine, for instance, and all of a sudden the machine stops. So it could be that there's a jam on the machine and it wants to clear the machine. In the process of doing this, the machine can restart and then chop off his hand, which is just there. You can also have a situation where a maintenance guy is working on a machine unknown to his colleague. Okay, the machine would have been put off, okay, during the course of the maintenance, but because maybe the technician's colleague is not aware, or any other person is not aware that a particular job is being done there, before you know it, he goes to switch it on. The guy's hand is there. What happens? The hand goes. So it's very important that we also implement hazardous energy control. And there's a protocol used in managing this, and that is what we call lockout and tagout and even tryout procedure. So what that procedure simply means that every equipment, first and foremost, before I even go further, should have, apart from emergency stop, should also have isolator switches. So even if the machine was built without it, once it's installed, of course, the isolator switches should be improvised on it, so long as it's effective to bring to a stop the machine. So what happens is that to manage the equipment and prevent it from causing injury during the course of either operation of it or quick intervention during operation of it or during maintenance of the equipment, the LOTO procedure needs to be applied. And what it simply means that the equipment needs to be isolated. How do you isolate it? You de-energize it. Once it's de-energized and then it's confirmed to be completely de-energized, the next is that a physical lock is placed on it. So the isolator switch is normally provided with a port or hole where physical lock can be applied to it. So you de-energize by switching off. You try it out to ensure that it's completely dead. Then the next is to put your padlock, so to say, on it, and then keep the key with you. So what that means is that until you energize it back, until you unlock the machine, nobody else can operate it. The machine, even on its own, cannot start. So it's very important that we understand this protocol, because it has actually helped in preventing very serious injuries on site. Okay, because there has been, if time permits, I could share a lot of experiences from various industries actually, where poorly managed hazardous energies has caused amputations and even deaths during the course of maintenance or running of equipment. So that is the very simple but serious and important aspect of machine safety that everyone. I'm mentioning this experience, these two. So machine safeguards needs to be in place, and then of course hazardous energy control protocols needs to be in place and also implemented during the course of quick interventions on machines, or even outright short-term maintenances of such machines. So engineering safety is such a broad aspect, and because of for want of time, I try to limit the discourse within these two aspects of machine safety. Okay, machine safeguards and also hazardous energy control. So it's already 8:31. I think it will be time good enough for me to now at least throw the floor open, receive questions or comments, so that we can discuss further from there based on questions that are going to come my way. This, in respect of the two aspects of machine safety we have discussed: machine safeguards and also hazardous energy control. Thank you, Dr. Osaze. So, hello.
Hello. Yes. Yes.
Yeah. So I've just landed on my point. I think at this point we should take questions or comments, so that from questions that will come my way, I'll try to answer them, and then in the process also explain further what we need to.
Okay. Just 1 minute, please.
Yes, sir.
Okay, thank you, Mr. Nelson. We are very, very happy with your presentation so far. I want to believe that you've done justice to a vital area of engineering safety, in as much as there is no time or there's time constraint in diving into the broad area of engineering safety. So in view of what you've done so far, please, if you have any question, just indicate by raising your hands, and we'll call on Mr. Nelson to respond to you. Please make your question very, very brief, maybe just 1 minute or 2 minutes. And I hope Mr. Nelson too, we just go straight to the point so that we can accommodate as many persons as possible. Okay. We are waiting for questions, please.
Yeah, yes, of course.
Just raise your hands up if you have any question, please. If there's no question, I think we have to. Okay.
No, there's one that is coming.
Yes,
I see.
Sunday Obaro. Sunday Obaro says, how can one spot hazardous energy at a glance, except if I don't get it well?
Okay, so what I said was that, every equipment is driven by one form of energy or the other. All right, the energy can be electricity, that's electrical energy. It can be pneumatic energy, that's talking about compressed air. Okay, that's pneumatic. It can even be hydraulic. That's why we have pistons and piston cylinders, and of course hydraulics in them. So it presses and then forms a force around there. So it can even be spring-loaded systems. Okay, it can be gravity acting on some objects, some parts of equipment that that if not properly managed can cause injury. So talking about spotting hazardous energy at a glance, what you rather need to understand is that, one, every equipment is driven by one form of energy or the other. So it can be electrical, it can be pneumatic, it can be hydraulic, it can be springs, it can be even steam, it can be all manner of things, so long as that is what makes the equipment to perform the operation it's designed to perform. And I said also that an equipment can have more than one hazardous energy driving it, okay, or playing a part or a role for the equipment to function as designed, okay. What is very common, of course, is electricity, okay, because almost every equipment is powered by electricity. So electricity becomes the primary hazardous energy, all right. Then, but depending on the design of the equipment, some equipment also have compressed air within them. That is pneumatic energy. Some also have hydraulic energy within them, like pistons, for instance, piston cylinders, for instance, that has what you normally call oil inside, okay, which helps it to perform its function, okay. Some can also have a steam running, becomes a part of hazardous energy also around there. So there are a whole lot. So it's not something that we can say at this point that just at a glance. Yeah, fine. We can still say at a glance anyway, because every equipment primarily driven by electricity. So at a glance, you know that, yes, this equipment is driven by electricity, right? So you may understand the other aspect of energy that may be there. But first and foremost, every equipment is mostly powered by electricity. So electricity is key hazardous energy that needs to be controlled. Yeah.
Okay.
So, yeah.
Okay, yeah, we have another question here. 𝗲𝗏𝗄𝗵 will it be important
so
to check?
I think, Doctor, Doc, I think we need to first go back to the
okay.
the first
Sunday
person
Obaro.
to confirm. Yeah, let's confirm that he's happy with the response. If it's
Sunday
clear
Obaro,
with it.
are you okay with that response? You can unmute yourself and.
Thank you, sir. Thank you, sir. I really appreciate it. I got it well now. Thank you.
Okay, thank you. Thank you.
Yes.
Okay, 𝗲𝗏𝗄𝗵.
Okay, thank you very much, Sunday Obaro.
Will it be important to check this safety device every day before operation? That's a question from 𝗲𝗏𝗄𝗵.
Okay, so Amadi is asking whether it's required, whether it's relevant to check the
safety devices,
for instance, the stop buttons or the isolator switches. Yes, on the equipment prior to start off the equipment every day. Your car, before you start any car, each morning, ideally you should do some primary checks, right? You open the bonnet, you check your gear oil, you check your water, you check all of that, just to ensure that the car is will start if you turn it on and also operate as you expect it. So I would like to say that yes, as an equipment operator, one of the key competencies of an operator is to do what we call pre-use inspection of his or her equipment. So if you resume at your workstation, before you go ahead to begin your work that day, you should do preliminary or pre-use inspection of your equipment. Part of the things you inspect, of course, will be that the guards are there. One, you inspect to ensure that the guards, the machine guards or safeguards are in place and also still functional. Then, of course, you need to inspect that, yes, the controls, the hazardous energy control switches are also in place. And why must you inspect? Should you need to do quick intervention during the operation of the machine, that's where the isolator switches come in play. But if you don't know, for instance, the health of the isolator switches, then when it's needed, which is during the course of your work, it may just fail you. So yes, it's also good that you inspect to confirm that the hazardous energy control devices are in place. But from safety point of view, from safety personnel aspect, we have inventory. Okay, let me give you this scenario. All my sites, okay, have inventory of all isolators, all hazardous energies on equipment. So we also have inventory of the isolator switches, okay, and even stop buttons on every equipment. Okay, so what do I mean by inventory? We know every piece of equipment that is on every site, on our site, right? We also know the functions of each equipment. So we know the locations of this equipment. And then we know the energies that drive the equipment, okay, alongside electrical energy, of course, electricity, okay? And then we also know the isolator switches, the kind of isolator switches and where they are. So we have that as an inventory. So what the team does is that routinely, within our part of our routine safety inspections, okay, safety personnel go around, inspect the safety devices on the equipment, including, of course, the machine safeguards as well, just to confirm that, one, they are available and still available on the equipment, and then they are also functional, implying that if need be, they will function as designed. So we do that from our own end. But of course, that does not also make the operator not to inspect his own. So the operator does what we call pre-use inspection, because he's the one there. The safety team does their own inspection periodically, depending on the schedule. Okay, it could be weekly, it could be every 2 weeks, could be every month, depending on the schedule. However, the equipment operator must carry out his own pre-use inspection, which should include inspecting and ensuring that the hazardous energy control devices, and also the machine safeguards are in place and also very functional. Thank you. Yeah, thank you.
Okay, thank you, Mr. Engineer Nelson, for that. I think we don't have any other question here. I want to believe Amadi Cyprian was properly responded to. Amadi, hope you are okay with the response.
Yeah, thank you so much. Thank you so much.
Okay, you're welcome.
Okay, yeah, thank you, Amadi.
Okay, any other question, please? Okay, so I want to ask Mr. Nelson for his advice for engineers, both upcoming engineers, experienced engineers. What is your advice to them as far as safety is concerned? And do you think this training, this certificate they are going to get and the training they've just gotten, will also help them in their quest to improve on their safety awareness at their place of work as engineers?
Yes, thank you very much, Doctor. It's a very good question. And I'd like to really take a little time to talk about this, okay? Now, engineers are actually, one of the very key personnel on site that are saddled with the responsibility of ensuring safety, okay? So a couple of incidents have happened due to poor maintenance, for instance, of engineering equipment or, production machinery. We have situations where engineers or technicians will work on equipment, open up the equipment, take out the guards or disable the guards, and then at the end of the maintenance, what happens is that they keep it aside. They just, so long as the equipment is running, they will fail to either deliberately or due to low risk perception, they will fail to return or restore the guards. Okay, and before you know it, the operator goes there to operate the equipment, and then incident results. So engineers have a very key role really to ensuring safety of the operation of every equipment that they maintain or they superintend over. So engineers are very important in ensuring safety, honestly, So, and that is why even in the hierarchy of controls, the third hierarchy says engineering control. Who are the people that perform or ensure engineering controls are in place? The engineers. There are a whole lot of engineering controls that we use to mitigate safety risk, especially involving machines and even non-machines. But of course, if they are put in place, they can go a long way to prevent or reduce incidents. So as per my advice, I like to advise every engineer here listening to me to take this very seriously. In fact, I sit in interview panels, okay, not really for safety roles, but for engineering roles, okay? And then my own aspect, I usually ask, of course, safety questions like what I've just said, we've just discussed, machine safeguards, hazardous energy controls, and some other aspect of engineering questions that relate to safety. And once I find that the guy or the candidate is, has little or no knowledge about safety, for me, that's a no-no. That's already a red flag. That means that if we go ahead and engage such persons, it's going to be a disaster on our side. Okay, so it really starts from there. So don't just look at it that it's already when you are in. You need to be able to demonstrate to your to anybody who cares or who is trying to hire you that you understand safety, that you are coming in to also work safely to ensure incidents don't happen. So engineers have very key roles. Like I said, engineers design machines, engineers run machines, engineers maintain machines. And incidents and even fatalities happen during the course of these various aspects of engineering practice on site. So if engineers do not know or understand the core basis of safety or how they can prevent incidents through their engineering practices, how can they really function very safely? So it's very important that engineers take this seriously. Okay, there may be conflicting demands, of course. Like an engineer who is only okay, there's production needs to start, a machine has been down for some time, and then the plant management is on you, the engineer or technician, to quickly get the plant started. You must not, no matter what pressure you are under, you must not compromise safety. Because I tell you something, where the chips are down, even that plant manager, for instance, that you are trying to please by passing safety protocols to get the plant started, we deny you, okay? Because they will tell you, yes, we wanted the plant to run, but we did not tell you to work on it unsafely or to render it unsafe. Okay, so it's very important that every engineer take this very seriously. Right from recruitment process, it's important that you exhibit or show that you understand safety and that you are willing to practice and ensure safety of the site you are going to work. And then when you're eventually in, you must also ensure that every bit of your work and the job that even others do are done safely. It's very important. It's always better to deliver than to explain. Because I tell you, when anything goes wrong, you, the engineer on site, may not be able to defend yourself. Because so long as there is a bit of negligence from your part, you will not be exonerated from whatever consequence management that will come with it. Thank you very much.
Okay, thank you so much. We appreciate your time. We also want to quickly state here that we will be having a school for further studies on HSC areas of focus, and it will interest you to know that you will be very, very happy to do some great courses with us. However, you'll be communicated, this information will be passed across to you through your emails or phone numbers when it is time. So just watch out for such information. So Mr. Nelson, Engineer Nelson, sorry, I keep saying Mr. Nelson. For the concluding part, what advice do you have? What do you have to say about safety, engineering safety, and safety in general? And what is a career path for those that want to chart out a course in this area, if there's any?
Okay, so I like to say that safety practice is very lucrative. It's actually well sought after. Okay, very, very lucrative. And I recruit safety personnel myself, and I tell you, when I'm providing the requirements for such vacancies of such roles to be filled, and I supply them to HR. I always mention that we want people that have engineering background. Okay, science background is okay, but mostly preferred is engineering background. Okay, so it's very lucrative. And then usually where to start is to start, of course, as you can't just jump the gun and go and start as a safety manager. If I mean, you need to learn the rules, you need to learn the rudiments, you need to start from somewhere. And then usually the best way to start is to start as a safety officer. All right. So you can start as a safety officer on any site. Could be a construction site, could be a manufacturing site. Okay, while you're on it, of course, you're upgrading yourself. Then from safety officer, you could have the next could be safety coordinator, the safety manager, safety lead or head of safety, safety GM, and even director of safety. I report to the vice president safety in Olam. So you can actually go as high as vice president or even president. Okay, depending of the function. So it depends on how this company is structured. So yes, there's a lot of prospects. There's a lot of prospects, and engineers who are safety practitioners are always first considered before others. I mean, I hire people, I tell you, and I receive a lot of CVs. There are certain CVs that I see, I just don't waste my time. Okay, maybe I see a CV or somewhere that I read, studied, for instance, I could get any of the management sciences, but I mean, you know, it could be you know, maybe mass comm. It can be anything. I'm not saying that, but the point is that without really, we need to call a spade a spade. It's like an engineer going to do a doctor's job. Okay, or engineer are going to do a lawyer's job, of course, the first consideration wouldn't be the engineer. Okay, so that's also the way it sits. Okay, though I do know that there are a lot of persons with different backgrounds or disciplines have come into safety. But when we look at the core aspect of the job, the understanding of the job, who should really easily perform well as a safety officer, of course, is the engineer, or at least the person with a science background. So engineers have very good prospects if they do wish to develop a career in safety. I myself, I studied mechanical engineering, and for the past 15 years, 16 years now, I've been into it. But of course, I did the usual maintenance engineering job. I worked at Drury Industries, Agbara, as a mechanical maintenance engineer. Okay, I did some work with them, and then eventually moved into safety. So, you know, so if you have an engineering background, it helps you to understand the risk better. It helps you to also understand the applicable control measures better. We just talked about engineering controls as one of the key hierarchy of controls of risk. If you're not an engineer, how would you be able to really provide such solutions, okay, when needed? So engineers are welcome, engineers are needed in safety. There's a whole lot to gain. The career path is also very, very good. And like I said, it's well sought after. Well, we are not many yet in Nigeria. So it's an industry that has not been, how do I put it, has not been over stretched. So even, yeah, those who are joining today, I can tell if you have the right qualification, like the one you just got, which is where to start with, okay? And then the next is to have the on-site experience where you begin to have hands-on experience. And from there, you can actually move from safety officer to safety coordinator to safety manager to safety lead, or, you know, manager, GM safety, then to director of safety, and even much higher than that. Yes, so that's my advice. So for those engineers, engineering graduates who are ready to join safety, please do.
Okay.
But just to mention, actually, you know, like I always say, also, it comes with it should come with a lot of passion. I mean, it's not a job personally I do just because of the money. You know, just look at yourself as being someone that is helping people to stay alive, to stay safe. Okay, so that for me is another huge motivator that I can't really quantify. So when I look at myself at times, I just know that I'm not just in this practice or this profession because of the money. Of course, money will come, you're working, you get paid. But I tell you, what should be the motivator, driving force, is the fact that you are helping people to stay alive by ensuring that they work safe. How do you ensure they work safe? You carry out risk assessment of their jobs. You recommend the control measures. You see that those control measures are also implemented. You train them. You provide procedures, okay, to guide them on how to work safe. And then you monitor as work goes on. And then, I mean, the cycle continues. At the end of the day, everybody is good, and workers come and work and go home safe every day, and you're happy. Thank you.
Okay, that is an excellent facilitation from you. It was such a nice one that I can't believe we covered so much within this short period of time. Let me see.
Yeah, there's what Henry I can see there. Mary, can you check out the message from Henry?
Okay, I can see Henry from 𝗲𝗏𝗏. Can this certificate take the place of that given by 𝗲𝗏𝗏𝗏? Because most oil and gas firms do request that we have safety certificate issued by 𝗲𝗏𝗏𝗏.
Okay, 𝗲𝗏𝗏𝗏 is, yeah, 𝗲𝗏𝗏𝗏 is Institute of Safety Professionals of Nigeria. Yeah, it actually used to be NISP, okay, Nigerian Institute of Safety Professionals, okay. Now, let me put it this way. 𝗲𝗏𝗏𝗏, certificate from 𝗲𝗏𝗏, you know, 𝗲𝗏𝗏𝗏 gives you level 1, 2, and even up to 3 competency certificates, right? And then, of of course, the certificate you 𝗏𝗏𝗏𝗏 is giving you is equivalent to that. I must tell you, is equivalent to that. If you look at the cost, because I've done this for myself. In fact, I did this for 2008. So how many years back? About 16 or 17 years ago. Okay, because at that time it was actually just, I could say it was just about 𝗲𝗏𝗏 was about the only organization around offering them such base level training. Okay, and then of course during the course of time, other training organizations like 𝗏𝗏𝗏𝗏𝗏 and a whole lot of others have come up. The most important thing is that you look at the content of the training. Okay, the content, as I know, is rich enough and is comparable to what you get from 𝗲𝗏𝗏. Do you understand? So oil and gas guys, because there's also this how do I put it? This mentality that maybe because 𝗲𝗏𝗏 is more like, you have the name Nigeria, whatever, Institute of Safety Professionals or Institute of Safety Professionals of Nigeria, because the way it's being coined, it looks like, okay, that is the supreme. And I can tell you it's not really, because I've gone through 𝗲𝗏𝗏 myself. I also know the content that some training organizations like Lafarge offer. So if you want me to rank them, I place them side by side, really. Okay, I place them side by side. Okay, and then for me, I think if I have to even choose, I will go for safety training like the one offered by 𝗏𝗏𝗏𝗏, because of course I know the training organization. I know the quality of the training they deliver. I've also seen the content of their training. So what else do I need to know before I accept that they are very good? Okay, so that's it. So just feel free to present this certificate to anybody. Okay, it's comparable to what you get from 𝗲𝗏𝗏𝗏. It's actually base level training for people wishing to enter into the career as safety professionals.
Okay, thank you, Engineer Nelson, for that response. I need to also assure everyone that, for soft copy of the training material, okay, you will be having access to the link on the site soon, where you can go through the materials anytime you want to go through the materials. And the materials on WhatsApp too will be there. We don't usually close our WhatsApp classes so that you can have access to those materials anytime. You can interact with the facilitators anytime. And I want to also let you know that 𝗏𝗏𝗏𝗏𝗏 has international accreditations, and ours is to ensure that Africans have access, unfettered access to world-class education without paying so much, without the need to travel, without so many bottlenecks that usually come with trying to school abroad and doing them online. As you can see, most online courses people take out outside this country or maybe whatever, you just do your courses online, you and the computer. But here in 𝗏𝗏𝗏𝗏, you have some element of face-to-face live sessions. You can talk to a facilitator on WhatsApp, you can talk to someone on Zoom, you can ask questions, and you clear your doubt about so many things. And that is one angle that hardly any other training institution is offering that makes us unique. Thank you so much once again, Nelson. Thanks to everyone that attended this program or that's going to be attending this program further on. And I want to say that you can be rest assured that you'll be getting the best. This is just the beginning. Let's put into practice whatever you've learned. Practice makes perfect. Your certificate or your stay in the class will not make you an overnight safety related engineer or have safety related competencies at your place of work. But your practice is what is going to make the difference and make you better. Like Engineer Nelson will tell you, he has been there for over 15 years. So those 15 years comes with a bundle of knowledge, experience, and so many things. And you can start this night. Thank you, and God bless you.
So thank you very much, sir. Thank you, and I wish all participants good luck. And,
yes. Thank you, everybody. The recorded version of this video will be sent to the class for those that are not here. Okay. Good night, everybody.
All right. Thank you and good night.
Good night, my dear.
Thank you. Good night, sir. Thanks so much.
Bye.
Thank you. Good night.
Good night.